sort of instrumental in creating the enterprise Java model, taking Java from applets to server-side and then building large-scale applications. Now, if you kind of look at our history for the last decade, there's been a lot of consolidation in things like, let's say, aircraft manufacturing. I mean, we may, in 10 years, have one worldwide aircraft manufacturer, by absorbing everyone else. If you look at the energy companies, there's been a lot of consolidation. So it looks like we're going to have, one company making planes, one company pumping gas. So if we have a similar trend in the software industry, and let's say the database industry as well, we get to the point that there'll be a single supplier. Will we have a need, or will there be concerns, let's say, over the next 10, 15 years for things being interoperable, for things like having portable code like Java is, so that you can take it from one operating system and one platform to another? Or are we going to see, Hewlett-Packard, Compaq merge, Sun, IBM, so that it's just going to be like one large computer company, which sort of obviates the need for having support for disparate systems, heterogeneous computing platforms?
Well, I certainly hope we'll have that problem, because if we've gotten down to only one vendor, we're not going to get any innovation left. I think interoperability and portability are important as long as there's multiple vendors pushing the software and the database industry in different ways. And there's really only 3 database vendors left: IBM, Microsoft, and Oracle, and, well, 3.5, all right, depending on how you count the others. So I was thinking about that when Jim Melton was talking about standards. It seems to me that SQL has actually gotten to a level of maturity that maybe a de jure standards slow process is appropriate for most of the changes, because you have the time to think through things that are going to affect millions of programmers out there. The standards process that I was involved in at the beginning with JDBC and later with the J2EE moves much faster. And that process worked very well. I was pleased that you had diverse vendors, Oracle, BEA, IBM, and so on, all with their different strengths cooperating on some level of portability and interoperability. When do I get to say controversial things in response to what the other panelists say? You're going to say that to the end?
Actually, you can go ahead and jump in now. I mean, while it's on.
Okay.
Well, by the way, just so everybody knows, after I get a chance to grill the panel, one of the benefits of organizing the session, we are going to take questions from the audience, so pay attention to what these people are saying if you have some questions. And we'll have people circulating with microphones when it's time for the audience Q&A. Go ahead.
Okay. Well, I'll pick on Don next to me. So I don't think people are going to, I think very few people are going to store and query data in XML format. I'm not investing in any XML databases. I think this seems odd for me to say, but I think the momentum behind relational databases is insurmountable. And I was on the other side of the fence on this on object databases 10 years ago. They've reached a plateau of maybe $100 million a year. So they have a niche market in telecom and various specialized applications, but they did not displace relational databases. And the argument was similar, that with object-oriented databases, you were already using an object-oriented programming language. The natural way to store your data was as objects. The XML argument is you're already interchanging your data in XML, and I do believe it will be the universal data interchange standard, but that doesn't necessarily mean you're going to want to store and query your data in XML. I'm not saying there isn't an XML database market. I think there will be a niche market for that, for caching data. I think there'll be a bigger market for things like an XML to relational data translator and tool for developers, and vice versa for developing apps that have to take pieces of relational data and store them in XML, or vice versa.
That sort of leads to the next question, Dana. I gave a briefing to some people about a year ago talking about things like global e-business. There have been these initiatives like EBXML and UDDI, and of course talking about these ubiquitous, like, smart programmable phones, 2 billion people with a programmable phone, and possibly exchanging, like ordering things, exchanging XML documents, that initiate at a phone and go through all these servers and may go around the world. So potentially, if global e-commerce reaches what people predict it will, we're talking about exchanging millions and millions of XML documents. Now, the numbers I showed a few minutes ago is that, if we're running a query that's dealing with tabular data, we can process 50,000 rows a second. We're now currently at the 3,000 document per second level with XML. And I guess, what do we see over the next 10 years? Are we going to be able to optimize XML queries to the point that we can do a much higher volume of processing of XML documents? When you're talking about shipping millions of documents back and forth around the world.
I'm personally extremely optimistic with respect to the performance of the XML databases, and I would like to support Don in his prediction that I think people will store XML natively and they will query them natively. I think we have a very, very good prognosis that we will be able to execute X queries as fast as we execute SQL queries. There is absolutely no inherent reason why X query should be slower than SQL. Obviously, we should not start the research from scratch. We should use all the algorithms and everything we know from the theory of optimization of SQL while re-implementing XQuery. But I think we have a very good chance that we'll have extremely good performance with XQuery. Now, I don't think that we have a chance to have such a good performance if we preserve the current status of affair. And here's why do I think so. If you look inside what the web services are built today, you see these three levels of impedance mismatch. The data is coming out of the web in XML. In order to do any kind of imperative programming, you do a first marshalling step, translating your XML data into some Java representation. And if you need persistency or transaction or anything like this, you need another step of data marshalling. You translate for your Java objects or C# objects into SQL. I don't think that we'll have good performance as long as we'll need this triple marshalling, XML to Java, Java to SQL, and back. And I think something has to be done there. And I strongly believe that in the future, probably not in the next years, but in the next 5 years, we will have programming languages that program natively against XML.
Okay, that's rather interesting. I guess, obviously there have been some people in the past who concentrated on things like SGML, and then when XML came along, I guess, I have a couple more questions that anyone on the panel can respond to, and then we'll go ahead and take audience questions. One of the things that people have really focused a lot on over the last year and a half is peer-to-peer computing, particularly for being able to do very large or solve very large-scale computing problems. And obviously, if we're talking about these massive databases that have to optimize queries, let's say, across distributed data that sits on 5 continents, that's a large-scale computing problem. So I guess one of the questions is, does anyone on the panel have an opinion or believe that peer-to-peer computing will play more of a role in database management in the next few years?
I think peer-to-peer computing raises a lot of questions about data ownership. I think if you have data that is easily replicated and you don't want to update it and it doesn't belong to anybody in particular, that's a wonderful application for peer-to-peer. But I don't think the Bank of America is going to be interested in that kind of architecture because they want to control access to their data much more closely than that. So I think it depends a lot on the kind of application.
Dana, do you have? Or Jim?
Jim.
People like Napster are a really great example of peer-to-peer, and that's unfortunately the data was not free, but they tried to make it free and got in trouble. SETI at Home is another really good example of peer-to-peer computing. And SETI at Home at a certain point got to be 1/3 of the bandwidth coming out of the University of California. And the university came to the SETI guys and said, stop that. And so what the SETI guys had to do was to make each computational step about 10 to 100 times bigger so that their bandwidth requirement was 10 to 100 times less. And the basic problem, and it's really troublesome for us is that it costs me $1 to send you a gigabyte. It costs you at least $1 to receive that gigabyte. I get a wholesale, and you probably get it retail. So that's the cost of internet bandwidth if you go off and rent it for $200 per megabit per month. That's what it turns into. So the problem with peer-to-peer computing for databases is that it's you have to send a lot of data around, and $1 will buy a lot of computing. Okay? So that's problem number one. And then the other problem is that MIPS are free. So harvesting. There's a lot of cars parked down in the parking lot down there, and we could all take those cars and put them to use, good use. But it's just way more convenient for your car to be there when you go down to the parking lot and to have a sort of one-to-one correspondence between people and cars. It's not economical. It's just convenient. And harvesting MIPS is harvesting a resource which is fundamentally free. And SETI at Home does it mostly because people like the screensaver. But it's not clear that very many people need this utility, which is lots and lots of free MIPS for computations that have almost no bandwidth requirement.
Do you have a comment, Rick?
Yeah, I was going to say that if you kind of squint at peer-to-peer computing and think of the World Wide Web as a bunch of servers that are talking to each other, search engines crawling other servers and doing peer-to-peer at that level, then I think there's a great growth market for a very large database of peer-to-peer computing. And I think one new promising area of database management is knowledge representation or knowledge management, where you try to build better search engines or better ways to find the things on this gigantic library of knowledge. And that may involve a little natural language understanding, AI, and it may involve a lot of database technology for a different kind of text-based, knowledge-based data. But I think that's a growth area for databases that are not relational.
We're having a conversation about that last month, where Dana and I were talking about would technologies such as the semantic web take off. And I guess fundamentally there's still the problem that we're adding an ever-expanding number of pages to the web. Huge knowledge base, like you said, to the point that it almost becomes unimaginable to try to figure out what kind of queries you can run that are going to return meaningful information, unless we really elevate the technology a level or two in terms of being able to describe the data that's out there and provide metadata for this very large-scale database. So that, again, when we think of computing in the large, we go back to this problem of if there are billions of people with devices that are connected that want to run queries, even though it may be a query behind the scenes because they're actually going to order something or they want to check the weather or something on their phone. That brings me back again to the question of database technology. Do we have the technology to support billions of people concurrently doing those kinds of things? And so I guess one of the questions is, where do we see the technology going in the next few years in terms of things like tuple spaces, T-spaces technology, in-memory databases, or are there some other solutions that we need to look at to provide database connectivity on that scale? Again, anybody on the panel? Go ahead.
Well, I think in-memory database is a no-brainer. I think probably most of the panel would agree that a lot of databases are getting to a state where they can be in-memory. And so there's still not enough computation power. You may have to put on memory on lots of machines in order to get the throughput that you want, but that seems like an obvious thing to do. Tuple spaces or Genie Java spaces type tuple spaces are an interesting new technology. There's both a database and a communication mechanism and an operating system in the sense that you can put things in this tuple space that is an association or a message that's going to be retrieved out of the tuple space from someone else. That I think is interesting, but I wouldn't predict that it's going to take over the world. I think it's still in an advanced development research kind of phase where a number of universities and bleeding edge companies are playing with that technology to see what they can do with that.